Okay, in this lecture video, I just wanted to go over a little bit about how we use the standard nomenclature to talk about fatty acids. And when we're naming a fatty acid using standard nomenclature, they're described by their chain length and the number of double bonds that they have. So let's do a couple of examples. The first one, the common name is myristic acid. And you'll see the common names a lot, but I'm not going to hold you responsible for those, but I will hold you responsible for being able to draw a fatty acid given the standard nomenclature and vice versa. So standard nomenclature for myristic acid is 14:0. So this is the number of carbons in the molecule, and this is the number of double bonds. So from that, we can see that myristic acid is a saturated fatty acid. It doesn't have any double bonds in it. So if I wanted to draw that structure, I would draw the carboxylate on the end, I almost called it the N-terminus, on the end. It's not the N-terminus. And then there's 14 carbons total, and that counts the one in the carbonyl. So don't be the person that forgets to count the carbon in the carbonyl. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And I'm drawing these. They look like they're trans, but remember there are no double bonds here, so we have rotation about all of these single bonds. So all of these carbons are tetrahedral. They are sp3 hybridized and tetrahedral in their three-dimensional shape, except of course from the carbonyl carbon. That one's trigonal planar. So 14:0, number of carbons, number of double bonds. So now let's do another example where we're going to incorporate some unsaturation. So in this example, we'll use arachidonic acid, another really common fatty acid. This one plays a big role as a precursor in the synthesis of eicosanoids, which are involved in all manner of signaling, so a lipid role in signaling within the body. So for example, registering inflammation and pain. So standard nomenclature for arachidonic acid is 20:4. And then in the parentheses, we have delta 5, 8, 11, and 14. So again, number of carbons is 20. Number of double bonds is 4. And up here, this tells us the location of those double bonds, specifically the first carbon in each one. So if we were going to draw the structure of arachidonic acid, it would look something like this. And we should also remember that the natural fatty acids are in the cis configuration. So unless it says trans up here in the location of the double bonds, unless it specifically indicates trans, then we want to make sure that we draw the double bonds in the cis configuration because that's natural fatty acids. So if we were to draw that, it would look something like this. So start with our carboxylate. So 20 carbons, and we got to remember there's going to be 4 double bonds at positions 5, 8, 11, and 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so here are our double bonds at carbons 5, 6, 8, 9, 11, and 12, and 14 and 15, and they are in the cis configuration. And don't forget, that's the first carbon as we added them up. So again, you're not responsible for common names, but you've got to be able to take a fatty acid, like given a structure like this, and name it, or you've got to be able to take the name and draw the structure.